we've been given a vector and asked to find its magnitude, direction, and direction angle. And I'm actually going to start by giving myself a little sketch of this vector. All right, so I have the vector minus 3i minus 4j. So I'm dealing with this vector, and there's my vector u. The magnitude is just the length of the vector. Direction angle, when I get ready to find it, is this angle theta. And the direction itself of a vector is a unit vector with the same length. So I'll be making this calculation at some point. So let's go on and find the magnitude of this vector. The magnitude of a vector u is the square root of the I component squared plus the j component squared. So here I have the square root of 9 plus 16, which of course is just 5. So there's the magnitude. I've done the first part. Now I'm asked for the direction, which is this calculation. So u over its own magnitude, a unit vector with the same direction as the given vector. So 1/5 times minus 3i minus 4j. Probably would usually just do this in one step, but apparently I felt like belaboring the point a little bit this evening. And there's my unit vector with the same length as my given vector. And now I'm just asked to find this direction vector, which if I think about it, I see a little 3, 4, 5 right triangle here. And well, they're not all going to be 3, 4, 5 right triangles. And what I know for sure is the tangent of theta is this length over that length. 4 over 3. All right, so let's see. Tangent of theta, inverse tangent of 4/3. Of course, that's not really going to be my angle. My angle's over there in the third quadrant, so I'm really finding a reference angle here, the little angle inside that right triangle. So I have my calculator here. Make sure I'm in the degree mode, because I want to think about this angle in degrees. I could do it in radians. I'm not really given any direction there. But I think thinking of this reference angle as 53.1 degrees is a good way to think about it. And my actual angle, I see I have to add 180 to that. 233.1 degrees. And there we have it. We have found the magnitude, the direction, and the direction angle of that vector. And even though we're not asked to do it, there's no reason not to just think about how we could write this vector down now as its magnitude times the cosine of that angle in the I direction plus sine of that angle in the j direction. Because a vector is always its length multiplied by its direction.